of the region between two circles are equal to 2 sin theta and 4 sin theta. So now to evaluate this polar integral, we must find the r limits and theta limits. So this is the region of integration. R equal to 2 sin theta is a circle symmetric about y axis with radius 2, and r equal to 4 sin theta is a circle symmetric about y axis with radius 4. Now we want to calculate the area between these two circles, r equal to 2 sin theta and r equal to 4 sin theta. Now to find the r limits, we draw the radius vector entering from the origin throughout the region R and identify where this radius vector enters the region and where this leaves the region. Since this radius vector enters the region at r equal to 2 sin theta and leaves at r equal to 4 sin theta. So r limits are from 2 sin theta to 4 sin theta. Now the angular theta limits are from 0, since theta starts from here 0 and it moves back to the origin at theta equal to 5. So theta equal to 0 to 5. Now our plug in these limits, our integral becomes r equal to 2 sin theta to 4 sin theta. Theta varies from 0 to pi r cube drt theta. Now how to evaluate this? To evaluate this double integral, first we integrate with our integrand r cube with respect to r, treating theta as a constant. Now integration of r cube is r power 4 by 4. Plug in these limits. Now substitute the upper limit 4 sin theta. This is 4 power 4 sin power 4 theta, which is 256 sin power 4 theta. Minus substitute the lower limit. This is 2 power 4 sin power 4 theta, 16 4 sin power 4 theta. Now what it becomes? 256 sin power 4 theta minus 16 sin power 4 theta. It becomes 240 sin power 4 theta by 4. Since 240 by 4 60, so this is 60. Take out this constant 60 out of the integration, 60 integral 0 to pi sin power 4 theta. Since to evaluate this integral 0 to pi sin power 4 theta, we are using the symmetry property. See, to calculate the area between 0 to pi, we are because of the symmetric property. This symmetric property means this is symmetric about y axis. The area from 0 to pi by 2 is same as the area from pi by 2 to pi. So that is why we are dividing this total area into two parts, 0 to pi by 2, pi by 2 to pi. So instead of calculating the area from 0 to pi, we are calculating the area from 0 to pi by 2 and multiply it with 2 to get the value of this integral. And so what it becomes? This becomes 60 into 2 times integral 0 to pi by 2. That means 120 into integral 0 to pi by 2 sin power 4 theta. Now to evaluate integral 0 to pi by 2 sin power 4 theta, we are using this reduction formula, that is Wallis formula shortcut. What is this? Integral 0 to pi by 2 sin power 4 theta d theta equals to n minus 1, n minus 3 and so on. That means we subtract this power 4 from odd numbers, 4 minus 1, 4 minus 3, divided by subtract this 4 from even numbers, first 0 and then 2 and so on. 4 minus 0 and 4 minus 2, which is in the denominator 4 into 2 and the numerator 4 minus 1 3 into 4 minus 3 1, 3 into 1 by 4 into 2 into pi by 2. So what will becomes 3 pi by 16. Now if you multiply this here, this 120 into 3 pi by 16. Now it becomes 45 by 2 after evaluating that.